Hello everyone, welcome to the HCIA-WLAN Huawei-certified wireless LAN engineer online training. WLAN technology has now become very popular and is widely used around the world. Experienced engineers should know that we are already using this technology extensively in our existing office networks. Everyone's mobile phones, computers, and tablets are using our WLAN technology, which now primarily promotes Wi-Fi 6 technology, accelerating WLAN deployment. Similar to 5G technology, the introduction of Wi-Fi 6 is undoubtedly a groundbreaking technology, as it is a breakthrough based on Wi-Fi 4 and Wi-Fi 5. Then, Wi-Fi 6 can be integrated with 5G, meaning that the future trend might be a collaborative relationship between Wi-Fi 6 and 5G. In this chapter, we mainly introduce the basic concepts of WLAN and the development history of WLAN. Then, we will discuss the current challenges WLAN faces and the solutions Huawei offers. Finally, we will look at the development trends of WLAN. Let's first look at the objectives of our course. Firstly, we hope everyone can understand the basic concepts and development history of WLAN. Secondly, we will compare the differences between WLAN and Wi-Fi. Finally, the typical application scenarios of WLAN. We will also discuss the challenges WLAN faces and its future development trends. Today's course is divided into 3 parts. The first part is an overview of WLAN, which includes some basic concepts. The second part deals with the challenges, discussing some of the issues WLAN faces in current networks. The third part is about solutions and what technologies we currently have to address these issues. Let's start with the first part, an overview of WLAN. Firstly, what is WLAN? WLAN stands for wireless LAN, meaning wireless local area network. Everyone knows about LAN. Previously, everyone played LAN games, where a series of computers were set up locally and connected together to form a local network, which we call a local area network. Currently, our local area networks are equipped with wireless cards, turning them into wireless local area networks, eliminating the need for cables. This means through wireless technology, a wireless local area network is formed. WLAN does not only include our Wi-Fi. Wi-Fi is just one of the technologies we use. There are others, such as infrared and Bluetooth. When you transfer data to your friend via Bluetooth or connect your wireless earphones with Bluetooth, it also forms a small wireless local area network. Zigbee is a technology used in the Internet of Things. Through WLAN technology, users can access the wireless network within a small range and work or live mobile, freeing themselves from the constraints of cables. Our wireless networks are divided into several categories based on their application range, one of which is called WPAN. WPAN stands for Wireless Personal Area Network, which is a short-distance network like Bluetooth, Zigbee, NFC, and so on. For example, Bluetooth might cover 10 meters, NFC even closer, and Zigbee is a power-efficient technology used in the Internet of Things. The second category is WLAN, which is the Wi-Fi technology we commonly see, with a coverage area slightly larger, possibly covering 20 to 30 meters and up to 300 meters in large setups. This is the general coverage range of Wi-Fi, from tens to hundreds of meters. WMAN is used within metropolitan area networks, mainly a WiMAX, which can cover several kilometers, generally used by operators employing WiMAX technology, generally not used by enterprises. Then there's wireless wide area network technology, which everyone is familiar with, like 4G, 5G. These generally cover several tens of kilometers, perhaps 4G covering a wider area and 5G covering a slightly smaller area. This is an overview of some common WLAN technologies, and then the size of our wireless local area network depends on how we deploy it. This chapter mainly talks about Wi-Fi technology. Next, let's look at the differences between WLAN and Wi-Fi. The first is the relationship of inclusion. Wi-Fi is actually a wireless local area network technology based on the IEEE 802.11 standard, meaning that Wi-Fi is a technology that adopts the IEEE 802.11 standard, a technology within the scope of WLAN technology, meaning that Wi-Fi technology is a type of WLAN technology. Another point is that the term Wi-Fi has no meaning and no full name. It is mainly used as a trademark of the Wi-Fi Alliance. Just remember that Wi-Fi is the name of an organization. The difference can be summarized as IEEE 802.11 being a WLAN standard, while Wi-Fi is an implementation of the IEEE 802.11 standard. This is the relationship between WLAN and Wi-Fi. Don't get confused about this later. Let's move on to look at the origins and development of wireless networks. First, a long time ago, in 1971, there was a concept, AlohaNet, which can be considered an early form of wireless local area network, including 7 computers, using a bidirectional star topology across 4 Hawaiian islands, with the central computer placed on Oahu Island. From this point on, wireless networks can be said to have officially been born. In 1973, the concept of Ethernet was introduced, with carrier-sense multiple access with collision detection. In 1980, the IEEE 802 standard was established, and Wi-Fi did not begin to develop significantly at this time. 85 was the official stage of WLAN development. First, the FCC opened the wireless spectrum ISM bands. After opening the ISM bands, we could use them for free, without applying. In 1988, a WLAN, an ad hoc network, was considered the prototype of Wi-Fi. Ad hoc will be mentioned later. Simply put, it's PCs, using wireless cards to connect, known as ad hoc, but without a complete Wi-Fi architecture, and had not yet formally formed a standard structure. In 1990, the 802.11 working group was officially established, and after this working group was established, it would promote the establishment of Wi-Fi technology standards. In 1993, AT&T released a 2.4 GHz WLAN, providing a 2 megabits per second rate, and completed the first WLAN at Carnegie Mellon University. Mass installation began. In 1996, Australia's John proposed the concept of Wi-Fi, and he is known as the father of Wi-Fi, who currently holds the copyright for Wi-Fi on behalf of the Australian government. So the copyright for Wi-Fi is currently held by the Australian government. In 1997, the first version was released, called IEEE 802.11/1997, which was basically not usable at the time, as the adoption of Wi-Fi in China was quite delayed, and at that time, the concept of Wi-Fi was unknown to most. In 1999, the predecessor of the Wi-Fi Alliance, called WECA, was established. The Wi-Fi Alliance is made up of many different companies. What's the purpose? We have many different manufacturers, such as Cisco, Ericsson, Panasonic, and other companies. These companies may have their own wireless products. The purpose of this alliance is to integrate different manufacturers' standards, or say their ideas and technologies, so that products from different companies have a unified standard. This is the purpose of the Wi-Fi Alliance, a commercial organization alliance formed by major companies. Next is the general development process of Wi-Fi, like our 802.11a, 802.11b, and then in 2000, WECA was renamed to Wi-Fi, and the first Wi-Fi certified product was released, meaning you submit your product to the organization. The Wi-Fi Alliance will review your product to see if it meets the requirements, conforms to the standards. If it does, they will give you a Wi-Fi certification. In 2003, the Wi-Fi Alliance released the WPA certification, greatly enhancing security. Subsequently, various technologies were introduced, especially in 2009, for the Chinese market. It was only after 2009 that WLAN technology really became widespread. The release of 802.11n significantly advanced the development of WLAN technology. Its usability, convenience are very useful. Before it was all wired networks, afterwards it gradually all started to become wireless networks. In 2013, 802.11ac was released. At that time, it was a breakthrough beyond gigabit speeds. In 2019, Wi-Fi 6 was developed. It supports 4G and 5G. Many users will switch from Wi-Fi 4 directly to Wi-Fi 6, skipping over Wi-Fi 5. This is the origin and development of wireless networks. So why do we talk in detail about the application of Wi-Fi 6 technology? Firstly, it's the significance brought by Wi-Fi 6. The Wi-Fi Alliance introduced a new naming in October 2018, introducing Wi-Fi 6, Wi-Fi 5, Wi-Fi 4, this industry naming every about 4 years. Wi-Fi standards will be updated, 802.11n, corresponds to Wi-Fi 4, 802.11c corresponds to Wi-Fi 5, and then Wi-Fi 6 is 802.11ax. These are the current mainstream 3 wireless standards. Different standards have different bandwidths and latencies. Different bandwidths and latencies also bring different applications. Why is 5G technology so popular? It's because of its large bandwidth and low latency. Wi-Fi 6 is popular for the same reasons. Being able to support more users with greater bandwidth and lower latency. Let's now look together at the 802.11 standards and Wi-Fi generations, starting with the 802.11 standard. We can see the initial 802.11b-a-g. Different these standards, the above few standards we basically no longer use. What everyone is familiar with is the 802.11n standard. Wi-Fi 4 is what we know as 802.11n, which can achieve a 600 megabits per second bandwidth. Wi-Fi 5 can achieve 3.47 gigabits per second. In 2015, Wave 2 reached 6.9 gigabits per second. Here, please note, it talks about theoretical rates. Theoretical rate can achieve 6.9 gigabits per second, but in reality, about 1 gigabit per second. This is because the technology of the manufacturers cannot achieve such rates, so it never reaches 6.9 gigabits per second. With Wi-Fi 6, we can see it can achieve rates of 9.6 gigabits per second, but from this theoretical data, it can be seen actually. The gap with Wi-Fi 5 is not large, just 3 gigabits per second, but due to a gap in actual rates. For instance, the best manufacturers might just exceed 1 gigabit per second a little. This is the limit that Wi-Fi 5 products can achieve, while for Wi-Fi 6, like Huawei, is already able to achieve 9.6 gigabits per second rates, so the bandwidth gap is over 10 times. This gap is very significant. Additionally, Wi-Fi 6 supports more user access. Aside from theoretical rates, if you want to be familiar with Wi-Fi related standards and generations, you must also be very clear about the operating frequencies. You can see that Wi-Fi 4 is still at the 2.4 GHz level. Then Wi-Fi 5 does not have 2.4 GHz. Wi-Fi 6 has this band again. This is also why we said earlier, some enterprises evolve directly from Wi-Fi 4 to Wi-Fi 6. Next, look at the development trends of Wi-Fi in our corporate office scenarios. First, in the early 90s, we were all desktop office. Then it was using portable machines with voice services, wireless services. Some hospitals, government agencies, and financial institutions have already started using wireless using 802.11bag standards. Mainstream technologies that everyone could access is in the third phase, the era of wireless office wired and wireless integration. Finally, currently it is evolving towards a fully wireless stage, large bandwidth. Everyone can achieve VR, AR, and 4K video, HR, etc. So this is a gradually evolving process. Different network technology developments and different product developments bring great convenience to our entire life, bring very significant changes. This part introduced an overview of WLAN, including WLAN development history, Wi-Fi generations, development trends. In the next section, we will introduce the challenges faced by enterprise WLAN and the solutions for the new generation of enterprise WLAN. Thank you, everyone. See you in the next class.